The National Electrical Code, also known as NEC, mandates a dedicated 20-amp circuit for both clothes washers and clothes dryers. This requirement stems from the significant current draw of these appliances. A 20-amp circuit is deemed necessary to prevent overloads and potential fire hazards. Despite a stacked washer-dryer unit potentially operating on a single 30-amp circuit, the NEC still stipulates a dedicated 20-amp circuit for each appliance. The reasoning behind this is that the NEC considers each appliance as an individual electrical load. While one might argue that a 30-amp circuit is adequate for both appliances in a stacked unit, given they are unlikely to operate simultaneously, the NEC doesn't accommodate such arguments. It insists on a separate 20-amp circuit for each appliance irrespective of simultaneous use. Therefore, adhering to the NEC, a dedicated 20-amp circuit must be provided for the clothes washer and another separate 20-amp circuit for the clothes dryer. To further explain the implications of this code requirement, let's delve deeper into the specifics. The NEC is designed to ensure electrical safety and prevent hazards. Its rules are based on the potential risks associated with electrical installations and appliances. The dedicated circuit requirement for laundry appliances is a prime example of this proactive approach. The current draw of a washing machine and a dryer, particularly during certain cycles like heating or spinning, can be substantial. If these appliances share circuit with other loads, or if the circuit is undersized, it can lead to overloading. An overloaded circuit can cause the circuit breaker to trip, cutting off power. However, repeated overloading can also damage the wiring, insulation, and the appliances themselves, increasing the risk of fire. The NEC requirement for dedicated 20-amp circuits is intended to mitigate these risks. By providing each appliance with its own circuit, the load on each circuit is reduced, minimizing the chance of overloading. It also ensures that each appliance receives the necessary power to operate safely and efficiently. Now let's consider the situation where a stacked washer-dryer unit is used. In this case, the two appliances are physically combined into a single unit. It might seem logical to assume that a single 30-amp circuit would be sufficient to power both appliances, especially if they are designed to operate in a way that prevents them from drawing maximum current simultaneously. However, the NEC doesn't make exceptions based on the design or intended usage of the appliances. It treats each appliance as a separate load, regardless of whether they are combined into a single unit or not. There are several reasons for this conservative approach. Firstly, the NEC is a general set of rules that applies to a wide range of electrical installations and appliances. It's not possible to create specific rules for every possible scenario. Therefore, the NEC errs on the side of caution and applies a uniform standard to all similar appliances. Secondly, the NEC is designed to be easily enforceable. If exceptions were allowed based on the design or intended usage of appliances, it would be difficult for inspectors to verify compliance. It would also create opportunities for misinterpretation and potentially unsafe installations. Thirdly, the NEC is based on the principle of redundancy. By requiring dedicated circuits for each appliance, it provides a backup in case one circuit fails. If the washer and dryer shared a circuit and that circuit failed, both appliances would be out of service. With dedicated circuits, only one appliance would be affected. Finally, it's important to remember that the NEC is a minimum standard. It sets the baseline for electrical safety. It's always permissible to exceed the NEC requirements, but it's never permissible to fall short. In the case of laundry circuits, it's possible to provide even larger circuits, such as 30-amp or 40-amp circuits, if desired. However, it's not permissible to use a circuit smaller than 20 amps for each appliance. So, in summary, while it might seem counterintuitive to require dedicated 20-amp circuits for each appliance in a stacked washer-dryer unit, the NEC rationale is based on sound principles of electrical safety, enforceability, and redundancy. Adhering to the NEC ensures that the electrical installation is safe, reliable, and meets the minimum standards for performance. While it's understandable to question the necessity of certain code requirements, especially when they seem to conflict with common sense, it's important to remember that the NEC is the result of decades of experience and research. It's a comprehensive set of rules that are designed to protect people and property from electrical hazards. Therefore, it's always best to follow the NEC, even if it seems inconvenient or unnecessary. In addition to the dedicated circuit requirements, the NEC also specifies other requirements for laundry circuits. For example, the NEC requires that laundry circuits be protected by a ground fault circuit interrupter, also known as GFCI. A GFCI is a device that detects small amounts of current leakage and automatically trips the circuit, preventing electrical shock. GFCIs are required in laundry areas because of the presence of water and the potential for electrical hazards. The NEC also specifies the type and size of wiring that must be used for laundry circuits. The wiring must be sized to handle the maximum current draw of the appliances. It must also be properly insulated and protected from physical damage. In addition, the NEC requires that laundry circuits be properly grounded. Grounding provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The NEC provides detailed guidelines for grounding electrical systems. These guidelines must be followed to ensure that the laundry circuit is properly grounded. In addition to the NEC requirements, there may also be local codes and regulations that apply to laundry circuits. It's important to check with the local building department to determine the specific requirements for the area. Local codes may be more stringent than the NEC requirements. For example, some local codes may require that all electrical work be performed by a licensed electrician. Others may require that all electrical installations be inspected by a certified inspector. Regardless of the specific requirements, it's important to ensure that all electrical work is performed safely and in accordance with the applicable codes and regulations. Failure to do so can result in fines, penalties, and potentially dangerous situations. If you are not familiar with electrical work, it's best to hire a qualified electrician to perform the work. An electrician will be familiar with the NEC and local codes and regulations. They will also have the necessary tools and equipment to perform the work safely and correctly. When hiring an electrician, it's important to check their qualifications and experience. Make sure they are licensed and insured. Also, ask for references and check them carefully. A reputable electrician will be happy to provide you with references and answer any questions you may have. In conclusion, the NEC requires dedicated 20-amp circuits for both clothes washers and clothes dryers. This requirement is based on the potential risks associated with electrical installations and appliances. By providing each appliance with its own circuit, the load on each circuit is reduced, minimizing the chance of overloading. The NEC also specifies other requirements for laundry circuits, such as GFCI protection, proper wiring, and grounding. It's important to follow all applicable codes and regulations to ensure that the electrical installation is safe, reliable, and meets the minimum standards for performance. If you are not familiar with electrical work, it's best to hire a qualified electrician to perform the work. By following these guidelines, you can ensure that your laundry area is safe and compliant with the NEC. Let's also address some frequently asked questions related to laundry circuits. Firstly, is it permissible to use a multi-wire branch circuit for laundry appliances? A multi-wire branch circuit shares a neutral conductor between two hot conductors. While multi-wire branch circuits can save on wiring costs, they are generally not recommended for laundry appliances. The NEC requires that each laundry appliance have its own dedicated circuit, which implies a separate neutral conductor. Shearing a neutral conductor can lead to overloading of the neutral, especially if the appliances are not perfectly balanced in terms of their load. Secondly, what type of receptacle should be used for laundry appliances? The NEC specifies the type of receptacle that must be used for each type of appliance. For a 20-amp circuit, a 20-amp receptacle must be used. These receptacles have a T-shaped slot for the neutral conductor, which prevents the insertion of a 15-amp plug. For a clothes dryer that requires a 30-amp circuit, a special 30-amp receptacle must be used. These receptacles have a different configuration of slots than 15-amp or 20-amp receptacles. Thirdly, is it necessary to use arc fault circuit interrupters, also known as FSIs, for laundry circuits? SIs are designed to detect arcing faults, which can be a common cause of electrical fires. The NEC has expanded the requirements for SIs in recent years. While SIs are not specifically required for laundry circuits in all jurisdictions, they are becoming increasingly common. It's best to check with the local building department to determine if SIs are required for laundry circuits in your area. Fourthly, what is the proper way to ground a laundry circuit? Grounding is an essential safety measure that provides a path for fault current to flow back to the source, tripping the circuit breaker and preventing electrical shock. The NEC provides detailed guidelines for grounding electrical systems. The grounding conductor must be connected to the equipment grounding bus in the electrical panel. It must also be connected to the metal enclosure of the appliance. The grounding conductor must be sized according to the NEC tables. Fifthly, can a 20 amp circuit be used for other outlets in the laundry area? While the NEC requires a dedicated 20 amp circuit for the clothes washer, it does not prohibit the use of other outlets on the same circuit. However, it's important to consider the total load in the circuit. If other appliances or devices are plugged into the same circuit, it could overload the circuit and cause the circuit breaker to trip. It's generally recommended to provide a separate circuit for any other outlets in the laundry area. Sixthly, what is the proper way to run the wiring for a laundry circuit? The wiring for a laundry circuit must be installed in accordance with the NEC. The wiring must be protected from physical damage. It must also be properly supported and secured. The wiring must be run in conduit or cable. The type of conduit or cable must be appropriate for the location and the type of wiring. Seventhly, can a flexible cord be used to connect the laundry appliance to the receptacle? Flexible cords are permitted for connecting laundry appliances to the receptacle, but they must be of the proper type and size. The flexible cord must be listed for the intended use. It must also be properly grounded. The flexible cord must not be damaged or frayed. It must be replaced if it is damaged. Eighthly, what is the proper way to install a GFCI receptacle in a laundry area? A GFCI receptacle must be installed in accordance with the manufacturer's instructions. The GFCI receptacle must be properly grounded. The GFCI receptacle must be tested regularly to ensure that it is working properly. The test button on the GFCI receptacle should be pressed periodically to verify that it trips the circuit. Ninthly, what are the common mistakes to avoid when installing laundry circuits? There are several common mistakes that should be avoided when installing laundry circuits. These include using undersized wiring, using improper grounding techniques, failing to provide GFCI protection, overloading circuits, and using damaged or frayed cords. It's important to follow the NEC and local codes and regulations to avoid these mistakes. Tenthly, what are the signs of a problem with a laundry circuit? There are several signs that may indicate a problem with a laundry circuit. These include frequent tripping of the circuit breaker, flickering lights, burning smells, and electrical shocks. If you notice any of these signs, it's important to investigate the problem and take corrective action. You may need to hire a qualified electrician to diagnose and repair the problem. By addressing these frequently asked questions, we can gain a better understanding of the requirements for laundry circuits and how to ensure that they are installed safely and correctly. Remember, electrical safety is paramount, and it's always best to err on the side of caution when working with electricity. The NEC is a valuable resource that provides guidance on how to install electrical systems safely and reliably. By following the NEC and local codes and regulations, you can protect yourself and your property from electrical hazards. It is also important to understand that the National Electrical Code is updated regularly, typically every 3 years. These updates reflect changes in technology, best practices, and safety standards. Therefore, it's crucial to stay informed about the latest edition of the NEC and any amendments or interpretations that may be issued by local authorities. Furthermore, remember that the NEC is a minimum standard. In some cases, it may be necessary to exceed the NEC requirements to ensure adequate safety and performance. For example, if you are installing a laundry circuit in an area with a high risk of moisture or humidity, you may want to consider using a more robust wiring method or a higher rated GFCI receptacle. The specific requirements for laundry circuits can vary depending on the type of dwelling, the location of the laundry area, and the local codes and regulations. For example, in multi-family dwellings, there may be additional requirements for common laundry areas. It's important to consult with the local building department to determine the specific requirements for your project. In addition to the NEC and local codes, there are also industry standards and best practices that can provide valuable guidance on installing laundry circuits. These standards are developed by organizations such as the National Fire Protection Association, also known as NFPA, and the Institute of Electrical and Electronics Engineers, also known as IEE. These standards cover a wide range of topics, including wiring methods, grounding techniques, and overcurrent protection. By following these standards, you can ensure that your laundry circuit is installed to the highest standards of quality and safety. Finally, remember that electrical work can be dangerous. If you are not comfortable working with electricity, it's best to hire a qualified electrician to perform the work. An electrician has the training, experience, and tools necessary to perform the work safely and correctly. They can also help you navigate the complex world of electrical codes and regulations. By taking these precautions, you can ensure that your laundry area is safe, reliable, and compliant with all applicable codes and regulations.